Here is the third and hopefully final video for section 3.4. And where we left off was with number 12. This next group here is a relatively simple way to do some proofs, but actually what we are going to do is we're going to prove the sum of the sum and the difference identities. And plus we may even change a lot of them. So we have sine of x plus pi over 2 equals the cosine of x. Now whenever we're trying to establish identities, we take the more complex side and go with it. So sine of x plus pi over 2, we have a sum identity, so that's sine of x cosine of pi over 2 plus sine of pi over 2 cosine of x. Let's see what we get here. Sine of x, okay, cosine of pi over 2, well, cosine of pi over 2 is 0, plus the sine of pi over 2, that's 1, and cosine of x, and this becomes 0 plus, doing the arithmetic here, we end up with the cosine of x, which is exactly what we needed to prove. Example number 13. The tangent of x minus pi over 4 has to equal the tangent of x minus 1 over 1 plus the tangent of x. Okay, here we have a difference for tangent, so that would be the tangent of x minus the tangent of pi over 4 all over 1 plus the tangent of x times the tangent of pi over 4. But its tangent of pi over 4 is equal to 1. So this becomes the tangent of x minus 1 over 1 plus tangent of x times 1, which is tangent of x. And so we get exactly what is being asked for. That is exactly what was needed to be proven. Example number 14. The sine of 3 pi over 2 minus theta has to equal negative cosine of theta. Okay, obviously this is the more complex side, so we're ready to go with this. The sine of 3 pi over 2 cosine of theta minus sine of theta cosine of 3 pi over 2. Well, the sine of 3 pi over 2 is negative 1. Negative 1 times cosine of theta times sine minus sine of theta times, well, the cosine of 3 pi over 2 is 0. Negative 1 times cosine of theta is negative cosine of theta, and anything times 0 is 0. So negative cosine of theta, which is exactly what we needed it to equal. Example number 15. The sine of alpha minus beta all over sine of alpha sine of beta has to equal the cotangent of beta minus the cotangent of alpha. Okay, this side is the more complex side, so I'm going to start with this. Sine of alpha minus beta is the sine of alpha cosine of beta minus sine of beta cosine of alpha. That's still all over sine of alpha sine of beta. Then I've got this expression up here and just one factor down here, so I'm going to give this to both the numerator and the denominator. So it becomes sine of alpha cosine beta over sine alpha sine beta minus, and do the same thing for the next one, sine beta cosine alpha over sine alpha sine beta. And then let's see, the sine of alpha will cancel here, and the sine of beta will cancel here, and then cosine of beta over sine of beta is cotangent of beta. Cosine of alpha over sine of alpha is cotangent of alpha, which is exactly what we wanted it to equal. So we have proven what we needed to prove. Example 16. Cotangent of x plus y, cotangent of x minus y equals 1 minus tangent squared x tangent squared y over tangent squared x minus tangent squared y. Now, it would seem that that's what we need it to equal. And it certainly would seem that we would probably want to try the right-hand side and try and factor that, because this seems a whole lot more crazy than this. So let's see what we've got. If we factor the numerator here, this becomes 1 plus tangent x tangent y times 1 minus tangent x tangent y all over tangent x plus tangent y times tangent x minus tangent y. Now where can we go with this? Well, if we look at grouping this one here, the tangent x plus tangent y, with the 1 minus tangent x tangent y, we group those two together and then group these two together here. Realize all we have are the reciprocals of either the sum or the difference of tangent. Well, the reciprocal of tangent is cotangent. So if I group these two together, this one here and this one here, that would be the cotangent of the sum, x plus y. Grouping these two together, it would be the reciprocal of the difference, x minus y, which is exactly what we needed it to equal. And so we have done exactly what was asked. And number 17, the cotangent of pi minus theta has to equal the negative cotangent of theta. Well, this is the more complex side, so let's deal with it. And cotangent is the reciprocal of the tangent. So that would be 1 plus the tangent of pi tangent of theta over tangent of pi minus tangent of theta. Let's see what we get here. The tangent of pi is equal to 0. So this becomes 1 plus 0. Since tangent of pi is still 0, it's 0 minus the tangent of theta. This becomes 1 over negative tangent of theta, which equals the negative cotangent of theta, which is exactly what we wanted it to equal, and therefore we have proven what we needed to prove. The final group asks us to find exact values. So number 18, we are taking the sine of arc cosine of 1/2 minus the arc sine of root 3 over 2. And so we need to do our calculations from previous sections. The arc cosine of 1/2. Where does cosine equal 1/2? That would be at pi over 3. Then the question becomes, where does the arc sine equal root 3 over 2? That is at pi over 3 as well. And so this becomes the sine of 0, which the sine of 0 is equal to 0. Finally, number 19. Number 19 is the cosine of the arc sine of 1/3 minus the arc tangent of 1/2 is equal to what? Well, it's going to be the cosine of something. Okay, I'm going to let this angle be alpha, this angle be beta, and then just go from there. So I need to draw some triangles here. Alpha, I know the arc sine is 1/3, so 1 1/3 would make this 2 root 2. If I do beta, tangent being positive, it's in quadrant 1. Likewise, sine being positive would be in quadrant 1. So we're all dealing with quadrant 1, and tangent would be 1 over 2, which would make this the square root of 5. So then it's going to become the cosine. This, if I let this be alpha and this be beta, we get cosine of alpha minus beta, which equals cosine alpha, cosine beta, plus sine alpha, sine beta. Cosine alpha, coming down here, would be 2 root 2 over 3. Cosine of beta, 2 over root 5, or 2 root 5 over 2 over 5. Plus the sine of alpha is 1/3, and the sine of beta is 1 over root 5, or root 5 over 5. Multiplying, we get 4 root 10 over 15 plus root 5 over 15, and combining into one big fraction, we get 4 root 10 plus root 5 all over 15.